Good afternoon, sir. This is Janvi from CSCA section, and my topic for CAA 2 assignment is Principle and Applications of HPLC Chromatography. So now, first outline, introduction, principle, parts of HPLC chromatography, types of HPLC chromatography, uses or application of chromatography, diagram of chromatography, pros and cons of chromatography. Next, introduction. So, high performance liquid chromatography, or commonly known as HPLC, is an analytical technique used to separate, identify, or quantify each component in a mixture. The mixture is separated using the basic principle of column chromatography and then identified and quantified by spectroscopy. HPLC is thus basically a highly improved form of column liquid chromatography. Instead of solvent being allowed to drip through a column under gravity, it is forced through under high pressure. So HPLC is a technique used to separate each component in a mixture, and the basic principle of HPLC is column chromatography. In column liquid chromatography, the solvent is dripped through a column under gravity, whereas in HPLC it is done under high pressure. HPLC principle. The purification takes place in a separation column between a stationary and a mobile phase. The stationary phase is a granular material with very small porous particles in a separation column. The mobile phase, on the other hand, is a solvent or solvent mixture which is forced at high pressure through the separation column. After leaving the column, the individual substances are detected by a suitable detector and passed on as a signal to the HPLC software on the computer. So, in the purification of liquid takes place in separation column, which is between stationary phase and mobile phase. The stationary phase is a granular material with porous particle. In stationary phase, it stays constant. The mobile phase, on the other hand, it is a solvent or solvent mixture which has movement. So after leaving the column, these substances are detected by suitable detector, and the detected or signals are passed as signals. So if we look at here, this is the HPLC. This is the HPLC column where stationary phase and mobile phase are present, and after separation of stationary phase and mobile phase, these are detected by the detector. Here it is the detector. These are detected by the detector, and the components are sent to the computer in the form of graph and recorded in the form of graph. So next, instrumentation of HPLC. First one, the pump. The development of HPLC led to the development of the pump system. The pump is positioned in the most upper stream of the liquid chromatography system and generates flow of eluent from the solvent reservoir into the system. So the pump, it is actually situated at the topmost of the liquid chromatography system, and it produces flow of eluent. Eluent is nothing but a carrier of mobile charge or solvent. Next, most pumps used in current LC systems generate the flow by back and forth motion of a motor driven piston. Because of this piston motion, it produces pulses. So it has a motor driven piston mechanism, and due to this mechanism it produces pulses. Next one, injector. An injector is placed next to the pump. The simplest method is to use a syringe and the sample is introduced to the flow of eluent. So injector is situated next to the pump in the diagram, and the simplest method in this injector is using syringe. Using syringe, we can introduce a new sample to the flow of eluent, and the most widely used injection method is based on sampling loops. The use of auto sampler or auto injector system is also widely used that allows repeated injections in a set of scheduled timing. So here in injector, the injecting of samples can be done manually or automatically by machines. Next one is column. The separation is performed inside the column. The liquids or the solvent separation is done inside the column. The recent columns are often prepared in stainless steel housing instead of gas columns. So let's look at next one, detector. Separation of analytes is performed inside the column, whereas the detector is used to observe the obtained separation. The eluent presence or absence depends on the analyte, and these differences are observed in a monitor in the form of an electronic signal. So from above, separation of liquid is done in column, and the separated mixture is determined in detector. Next, recorder. Electronic signals obtained in the detector are recorded in the form of graphs or molecular weight based calculations on a paper or printout. So the above detected signals are sent to a computer and recorded in the form of graph or molecular weight based calculations. So next one is degasser. Eluent or solvent which is used in LC process consists of other gases. These gases are detected as a noise and causes unstable of the particles. So the degasser is used as a special polymer membrane tubing to remove gases in mobile phase. So in above mixture, not only mobile phase and stationary phase, there are also some gases which are unnecessary. So these gases are removed using degasser. Degasser is a membrane having tubing structure. Column heater. In order to obtain repeatable results, it is important to keep consistent temperature conditions. Thus, columns are generally kept inside the column oven. So, in the experiment, to get constant values repeatedly, it is necessary to maintain a moderate temperature conditions, and this can be done by using column heater. And this is the original diagram of HPLC chromatography, which has solvent, pump, injector and HPLC column, system for monitoring the graph and a recorder or printer. Next, types of HPLC. Normal phase HPLC utilizes a polar stationary phase and a non-polar mobile phase. Reverse phase HPLC employs a non-polar stationary phase and a polar mobile phase, commonly used for separating organic compounds. Ion exchange chromatography separates ions based on their charge using ion exchange resins as the stationary phase. Size exclusion chromatography sorts molecules based on size. Larger molecules elevate faster than smaller ones. So normal phase HPLC, it uses stationary phase as polar and mobile phase as non-polar. In reverse phase HPLC, non-polar stationary phase and a polar mobile phase is utilized, and it is commonly used for separating organic compounds. Whereas in ion exchange chromatography, it separates ions based on their charge. In size exclusion chromatography, this sorts molecules based on size. So these are the types of HPLC chromatography. Let's look at applications of HPLC. The HPLC has developed into a universally applicable method so that it finds its use in almost all areas of chemistry, biochemistry, pharmacy, and also in botany. So the applications are analysis of drugs. It is used to analyze the drugs, and analysis of synthetic polymers, analysis of pollutants in environmental analytics, isolation of valuable products. So HPLC is also used for the isolation of valuable products, product purity and quality control of industrial products and fine chemicals. So it is used to test the quality and purity of industrial products also. Separation and purification of biopolymers such as enzymes or nucleic acid. As from the above, it not only uses it for separation of solvents or mixtures, it also used for the separation and purification of biopolymers also. And finally, water purification. Now let's look at the advantages and disadvantages of HPLC chromatography. Advantages of HPLC are speed, efficiency, accuracy, versatile, and extremely precise. The process is very speed and it is efficiency and it has accurate values and versatile and extremely precise. It can be used or it can be experimented on different kinds of mixtures components. So these four are the advantages of HPLC. Now look at the disadvantages. High cost, high quality components are needed. Research and development cost, need a skill to run the instrument. So it is very cost and only quality components can be used, and research and development cost is also very high, and to perform the experiment the person should have a minimum basic skill to run the instruments. So these are the advantages and disadvantages of HPLC. Thank you.